Okay, we're going to talk about stem and leaf plots now. The last lesson, the screencast lesson, was on histograms, and we went through driving times to get to work and stuff like that. This one, we're going to spend with a new type of plot called a stem and leaf plot. I'm going to talk about how to set one up, then I'm going to give you one and tell you how to read it, and then we're going to talk about the benefits and the limitations to a stem and leaf plot. Okay, first of all, one of the questions I had is, who uses a stem and leaf plot? And it's basically anybody who wants to keep their data organized in a nice, clean, and compact fashion, and that you can easily look at and say, oh, there's that data point, there's that data point. Histograms, remember I said one of the things that was not so good about a histogram is that you can't look at it and say, oh, there's all the individual data points. You can't see that because they're all covered up by a bar. You know, we just used a bar to show, but we couldn't see individual data points. The stem and leaf plot, we actually can. I'll show you what I mean. Above me, let's say that I had a math class and I had this many students. I have, 15 students, and they all took a test. And these are the scores that I collected after grading that test, okay? Right now it's just kind of a big jumbled mess of scores. It's raw data. I haven't done anything to it. I just wrote them down as I graded them, and that's what they look like. And I would like to see these in a more organized fashion so I can kind of get a quick at-a-glance view of what's happening in my math class, okay? So here's how I do this. This is called a stem and leaf plot because it has a stem, just a line up and down, and then it's gonna have a bunch of little leaves, and you'll see what I mean in a second. There are two sides to this stem, all right? I'm gonna break this down by class. They actually call this side of the stem classes. And what I do with that is I look at my data and I say, okay, what kind of place values do I have in this data? I have all 2-digit numbers, right? So all of my data has a tens place and a ones place. Some of my data later on, or actually I have some that have a hundreds place too. So I have three place values. And sometimes you can end up with data with decimals and thousands and 10,000s, and we'll get into more of those a little bit later. But for 6th grade, we're gonna keep it relatively basic, okay? So looking at my data, I do have a couple of perfect scores, and actually a better than perfect score, extra credit. So I'm gonna look at this and I'm gonna say, okay, I have tens place and ones place, and then I have these two right here that have hundreds places. Now over here is where I'm going to put my leaves, okay? Over here is where I'm gonna put my classes. And I don't mean classes like math classes. I mean anything that's not a leaf. Now what is a leaf? Well, a leaf is almost always, in fact, I think it is always, the place value that's furthest to the right, okay? In other words, every single one of these data points, their ones place is gonna be a leaf, okay? Classes are how I'm gonna organize the other place values, okay? So I have, in the other place values, I have tens and I have hundreds. Or you could look at this and say, this is 10 tens, right? So here's how I'm gonna organize the classes. I'm gonna look at my lowest score. Where is the lowest score? And it looks like 44 is probably the very lowest score I'm dealing with. I'm gonna take that place value, that number in the tens, and I'm gonna put 4 for one of my classes. That's the lowest of the classes, okay? What is the highest? Well, I have 4, I have a 5, here's a 6, 7, 8, 9, 10. There's nothing higher than a 10, right? So I'm going to use that as my highest, and I'm going to number these so that all of my classes are represented. Now, a little bit later, you're gonna see that you can't skip classes either. Let's say I had no scores in the 50s. Well, I still have to put a 5 here. Okay, you can't skip because that'll skew your data and make everything wrong. But I don't have to worry about that because it looks like everything's represented. So I have 4, because there's a 40 up there, 5, because there's a couple of 50s, 6, 7, 8, 9, 10. And I'm gonna extend my stem a little bit, okay? This represents my lowest and then all the way to my highest class. Does that look good? And then over here, in order, okay, in order, I'm gonna list the leaves, the ones places on this side for each class. This class is easy because there's only one score in here that's in the 40s, and that's 44. So I'm gonna put a 4 for a leaf. Notice this reads 44. Easy. Now let's add some more leaves, because look, there's more than one for 50s, right? In fact, I think those are the only two. So what's the lowest one? 50. So I'm gonna put a 0 here in the leaves. Then I'll look at the next one, 53. The 50 is already here, so I'm gonna put the 3 right here. Okay? Stop for a minute and look at this. Make sure you're okay with the fact that this right here represents two different scores, and they're both in the 50s. I have one that says 50 and one that says 53. Okay, let's jump to the 60s. Looks like the lowest score in the 60s I have is 62, so I'll put 2 for that leaf right there. And then the next biggest one is 3. Same thing, I have 2 scores, 62 and 63. Okay? How about 70s? Looks like I only have 2 of those also. I have a 75 and a 77. And then we'll move on to 80s. 80s has, looks like 3 of them. The smallest one is 82, so I'll put a leaf of 2 right there. Next biggest one is 83. And the next biggest one is 87. Another thing you kind of want to try to do, so it doesn't get all jumbled up and hard to read, is try to keep these numbers kind of in a nice column. Not necessarily because it's going to mean anything, it just makes it easier to read. Okay? 90s. Where's my lowest 90? Here. 91. And then 92. And then a 95. So there's 3 scores, 91, 92, 95. And finally, those scores that were in the hundreds, or 1010s. The smallest one is 100, and the next one is 102. Okay, I'm gonna go ahead and count my leaves so that I can make sure I got all my scores. I know there's 15 scores up here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I got all my scores on there. Okay, so if it's okay with why I set this thing up the way I did, now we can kind of look at it. One of the nice benefits about a stem and leaf table like this, a stem and leaf plot, is that it's very simple. Instead of trying to dig out through all this raw data to see your lowest score and your highest score. Okay, lowest score is right here at the top, 44. And then I go all the way down to my highest scores, and I can see 102 is the highest. Okay? Another benefit to this is if you can imagine kind of taking this stem and leaf plot and tilting it like this, it basically makes a histogram. Okay? With ranges in the 10s, kind of makes a histogram. If you tilt your head this way and you look this way, you can imagine the bars, right? But the nice thing about this, and you don't get this with a histogram, is you can see individual data points, right? So that's kind of a nice thing. If you ever had to come back and look at individual scores, you would be able to see them, but you can also see kind of how they stack up, right? I can kind of see that these two, the 80s and the 90s, would have bigger bars than all the others. But I can also see their individual data points, and that can be handy. We'll talk more about why that's handy when we get into box plots, okay? We're missing one more thing though, all right? We have to make sure that when we show this to somebody, they know what it means, okay? This doesn't really tell them anything, and you're not ever really gonna put headings. Like, you're not gonna put I mean, you will give it a title. You'll say math class scores or something like that. But these columns only mean numbers. So you have to make a key. You have to make a little thing over here that says, this is how you read this. All right? So I'm going to take, you can either use one of these data points or you can just make one up. And I can say 6 with that stem in the middle, 3 equals 63. And if you wanted to, because these are math scores, you could even say that that means 63%. You don't necessarily have to put the percent, but the important part is you say, you're telling the person who's reading your stem and leaf plot, if there's a number, if there's a stem in between two numbers, it means this is the tens place, this is the ones place. This is what it means. It seems like it's so obvious, right? But it's very important that you put a key for your stem and leaf plot, okay? So that's how we take raw data and we put it into this stem and leaf plot. Remember that leaves are always going to be the rightmost place value, okay? The classes will always be how are you going to organize all the other place values and make sure they're in order from least to greatest, and make sure that your leaves are also horizontally from least to greatest. It's important, okay? Now I'm going to give you a stem and leaf plot, and we're going to play around with some ideas for a minute. We don't need this data anymore. We're not going to visit those math scores until we make a box plot in the next lesson, but don't worry about that right now. Let's talk about, my niece is a violin player. She belongs to kind of a violin troupe, and it's all ages there. It's crazy. There's all kinds of people there. And when they do a recital, they let everybody play. They either play a solo, or they might do a duet where 2 of them play at the same time. They may have a quartet where 4 of them play at the same time, okay? And it's kind of important for a person who's running a place like that to kind of keep track of the ages of the people who are in this troupe. So let's say that the person who's running this deal keeps track of these ages in a stem and leaf plot, because what better to keep everything all together, organized, and in order. So here's what it looks like for this music troupe. I'm going to go ahead and make this and 1, 2, 4. All right. And the key we'll just pick 1 and 2 equals 12 years old. Okay, notice I put a label on there. The title of this stem and leaf plot is ages, okay? So these are the ages of the people that are in this recital troupe. You go to a recital and you watch the whole thing, and hopefully the data matches what you see on the stage. So I want to ask some questions about this. First of all, what is the youngest performer? What age is the youngest person who is performing on that stage? If these classes are the tens place and all the leaves are ones place, we should be able to see that the youngest person doesn't have a number, it has a 0 in the tens place and a 5 in the ones place. So the youngest performer on stage is 5 years old. How cute, right? How old is the oldest performer on the stage? Can you see that? If I go to the highest tens place and I look at its leaf, I can see that the oldest performer is 32 years old. Told you, there's a broad range of people there. And that word range, by the way, we'll talk about in a second. So tell me, which of these classes have the most performers in it? Okay? Are you going to see more people under the age of 10? Are you going to see more people between the ages of 11 or 10 and 20? I'm sorry, 10 and 19? Are you going to see the biggest number of performers between the ages of 20 and 29 or 30 and 39? If you look at this, we can see the biggest number of leaves, the most leaves are attached to this one, right? So most of our performers, if you were to compare them to all the other classes, most of the performers are in between the ages of 10 and 19. Okay, we can't fit 20 on this because 20 is right here, right? Can you see that okay? Okay, so what is the difference? What is the range of the ages of the performers? In other words, if I ask you what's the range of the ages of these performers, I'm asking you what's the difference between the oldest and the youngest performer, okay? This is a word that we're gonna spend more time with a little bit later, especially with box plots, and when we're looking more and more at how to analyze the data. But I wanna go ahead and ask you that now. What is the range of the ages? If I look at the oldest performer, and then I look at the age of the youngest performer, I'm just looking for the difference between those two. In other words, I'm gonna subtract 5 from 32, okay? So the range between the ages is 27 years. I just looked at the oldest and subtracted the youngest. 27-year range. That's a pretty big range, okay? That's literally like an all ages group, okay? So we got our key, we got the range, we practiced how to set up a stem and leaf plot, and then we also spent a little bit of time talking about how to read one, all right? Again, if you were to take this thing and flip it like this so that it made a histogram, you would see this bar up to about here. This bar is higher, way up to here. This bar is a little higher than the first bar, and this bar is little, okay? But again, the nice thing about a stem and leaf plot as compared to a histogram is that if I needed to, I could go in and see all the individual data points. Where with a histogram, I see a nice, pretty easy to access picture of the overall story, all right? As the leader of a recital troupe, I might want to have more in-depth knowledge. I might want to have more specific knowledge of their ages, okay? So go ahead and check out my exercise sheet right underneath this, because I'm going to give you a chance to do those two things again. I'm going to ask you to create a stem and leaf plot and then answer questions about it, kind of like we did with this right here, okay? I'll see you when you're done with that.